Section 1.1. We're going to now do some challenging examples. The reason I call these things challenging is because the book put a star next to the problem, and that usually means they're somewhat harder. First, let's look at this problem. Suppose A and B are positive, 0 less than A less than B, so B is bigger than A. You need to show that A is less than square root of AB, which is less than A plus B over 2. Okay. Now to show this thing, the first step is faster. So to show A is less than AB, you just say A equals the square root of A times A. We can take square root because A is positive, so don't we have to worry about anything, which is less than square root of A times B. Okay, because it's a bigger number than that. So therefore, the first part of inequality is proven. Now, what about the second part? Now, to do the second part of the inequality, we consider this particular thing. Suppose you have this. I'll write this down. Minus. Now, this statement is true because B is bigger than A. So the difference between their square roots is going to be a number that's not 0. And then when you square it, it becomes positive. Therefore, it's bigger than 0. Now, why would I say that? Because we're going to get this to come out to look like that. So when you multiply this thing out, you get A plus B minus 2 square root of AB bigger than 0, which will come out very nicely. So then A plus B will be bigger than square root of AB and then divided by 2. And that is the end of the second part of the proof. See, very nice problem. The second challenging problem we have is, again, 0 is less than A less than B. And now we have to show this thing. And we have to define an odd-looking thing that looks like this. 1 over H equals 1/2 1 over A plus 1 over B. You have to show that H is between A and B. Okay? There's actually a name for this thing. It's called the harmonic mean of the two numbers. And that right there is called the geometric mean, this thing right here. Well, whatever it's called. The point is, we have to show this. Somehow H is between A and B. Now this looks much more complicated, but it looks a lot easier if you consider this. Let's say if X, let's say we have two positive values, X and Y, where Y is bigger than X. Okay? Then it's true that X is less than the average of X plus Y, which is less than just Y. The reason is because if you average X with a number bigger than itself, then it clearly will be bigger than X. To explain it, go down to explanation, you can see, for example, the X is equal to 1/2 of X plus X, which is going to be less than 1/2 of X plus Y, because Y is bigger than X. And the Y part is the same thing. In any case, this equation stands, and that's what we're going to do. Okay? Now, so we will let so since A is less than B, it goes that 1 over B has to be less than 1 over A. Okay? And when you flip it around, you push B down here and put A down there. So then you get this equation, inequality. So then if we let X equal to 1 over B, Y equal to 1 over A, and plug this thing into here, then we get 1 over B less than 1/2 of 1 over b plus 1 over a, which is less than 1 over a. And this whole thing is 1 over h, okay? 1 over h. So then we have rewriting this, we get 1 over b is less than 1 over h, less than 1 over a. Now, rewrite this part of the inequality, we get h is less than b. So we get h is less than b from this part of the inequality, and from here we get h is bigger than a. So together we have h is between b and a. And that is exactly what we're trying to prove. And that comes out quite nicely. Now we're going to do one more problem, which I will erase this part here. And we just show one more challenging problem. That's problem number 3. Problem number 3 says that if, again, we have 0, a less than b, a and b are positive, you need to show that square root of a, square root of b, show that square root of b minus square root of a is going to be less than square root of b minus a. All right. Now, how would you do that? Now, first you will do a rough draft. So we shall do a rough draft. That means you're not going to show this part of the proof to your professor. So the rough draft is, what if this is true? What would happen? Let's being that it's a square root, let's square both sides. Now, the squaring both sides will preserve the inequality because you're multiplying both sides by itself. So we'll have b minus a here. And this thing becomes b plus a, okay, minus 2ab. And then if you simplify this thing a little bit, you will have, this side will be 2a less than 2 square root of ab. All right, so if this were true, this would be true. Now, is this true? Well, it is, because b is bigger than a. So 2a is less than 2ab. So that's how we're going to proceed the proof. But as I said, this is the rough draft. Do not show this on the paper. We're going to actually do the proof a different way. Okay, so you erase the stuff or copy over or something. This is the rough draft. Okay, now here comes the formal proof. Now that we know that, we will do the formal proof this way. We'll start here. We'll say 2a is equal to 2 times a times a square root, okay, which is going to be less than 2 times square root of ab, because b is bigger than a. That's given. Okay, right here, b is bigger than a. So in other words, if you erase this part, it looks like you pull this out of thin air. It's like a trick. And then we will, so rearranging this, we say 2a minus 2 square root ab is less than 0. We are trying to drive at this equation right here, which is, again, hidden. You need to erase that so that nobody knows where you got it. So then to get there, we need to add a b to each side. So you add a b to each side, and then you put 1a on the other side of the inequality. So you have b plus a, and then b minus a here. So we add a b to each side, move 1a, and then keep the rest of the stuff. You get 2ab. So we got here, okay? So far, so good. Now this thing will factor it, do reverse of this step. So then this is actually b minus a square root of b square root of a squared. If you multiply this out, you'll turn into this. See, same as here, which is less than just b minus a. And given that b is bigger than a, we can take the square root and the inequality sign will still hold. So taking the square root, we get b minus square root of a is less than square root of b minus a. And that is exactly what we're trying to prove. Remember, erase this part. That way nobody knows where you got this. And it looks like a genius trick that you pulled out of thin air.